Hi, so today I'm going to be showing you guys how to solve a problem for finite geometry. Okay, so we're first going to begin by looking, this is the answer and this is what I came up with. And I'm going to try and prove what we must prove. It says it has exactly 6 points and each line has exactly 3 points. So we want to make sure that this geometry construction proves these 2 points, that it has 6 points and that each line has exactly 3. To do so, we have to look at the axioms that were listed. So these are basically assumptions that we have to go off by. And the first one is there's exactly 4 lines. So I will show you here. This is line 1, so A. And then line B is this one in red. And then line C is this teal one. And then D can be this pink one. So those are my 4 lines, and you can see pink goes here, green here, purple, and then red. All right, so we have exactly 4 lines. And then axiom number 2 says any 2 distinct lines have exactly 1 point on both of them. So what that means is that there is a point. Every 2 lines has a point touching. So for example, here C and D both touch this point. C and B both touch this point. A and B both touch this one. D and A both touch this. B and D both touch this one, and so on. So any 2 distinct lines have exactly 1 point, and that is correct. And as you can tell, that every point has at least every 2 lines have at least 1 point touching them. And then the third one would be each point is on exactly 2 lines. So that's similar, but it's different because what that means is that each point on here, so we have 1, 2, 3, 4, 5, 6 points, has 2 lines, at least 2 lines touching it. So this point has C and D touching it. This one has D and B touching it. This one has B and C crossing through it. And then this point has A and C. This point has A and D. And then this point has A and B passing through it. So we have proved that that's right. So now that we have said that all of our assumptions are correct, we look at what we have to prove. So it says it has exactly 6 points and each line has exactly 3 points. So let's see if we have exactly 6 points. We have 1, 2, 3, 4, 5, 6. So that's correct. And then how we can tell that this is a correct finite geometry problem is because we can look at this and it says each line has exactly 3 points. So that's kind of going back to any 2 distinct lines have exactly 1 point on both of them. So that means that because that is the way it is, so because every 2 lines have at least 1 point on them, then we can't have less lines touching 1 point. And for this one, it says each line has exactly 3 points, so we have to count. So this purple line right here, line A, has 1, 2, 3 on it, right? No more than 3. And then this red line has 1, 2, 3. That's no more than 3. And then C here has 1, 2, 3. And then D has 1, 2, 3. And every point is being touched by at least 2 lines. So that is why we can prove that this geometric construction has exactly 6 points and each line has exactly 3 points.